Hey everyone, welcome back to another Lit in Space Lightning Pod. This is Alessio, partner and CTO at Decibel, and I'm joined by Swix, founder of Small AI.
Hi. We are very happy to finally have Dr. Jasper Jang of Hyperbolic on the pod. Welcome.
Thanks for inviting me. Great to be here.
Yeah, the story of Hyperbolic, I feel like we will do a full podcast on Hyperbolic at another time, but maybe like a quick 2 seconds on what's Hyperbolic, and then we can go into the IMO stuff.
Yeah, sounds good. Yeah, so I'm the CEO and co-founder of Hyperbolic, and I face like a lot of pain when I trying to get access to GPUs during my PhD time and also my serial time. So I decided I want to make sure that any AI team who want to build or use AI in the future, they won't get constrained by compute. And so we decided to build Hyperbolic, which is the on-demand AI cloud made for developers, so everyone can get fast, affordable access to compute and inference.
Yeah. By the time that we release this episode, we should be publishing Jasper's talk at AIE as well, so you can go over to his talk and see more about the story there. But we're actually coming here today to talk about something slightly different, something that you also have experience in, which is math Olympiads. The sort of headline, not to bury the lead, is that both DeepMind and OpenAI have claimed to have gold medal level performance at the IMO, and then you started being like super involved in like sort of breaking down what the story is. Maybe can you sort of recap what happened, and then we can go from there?
Sounds good. Yeah. So on Friday, so I like participate in different math Olympiads in the past, won a few gold medals, and I have a lot of friends who are actively involved in IMO, and so I was just chatting with my friends on Friday, and around like 3 p.m., one friend told me that, wow, China team won the IMO again, and also DeepMind also won the gold medal. And so I just started posting on X. I mean, I try to let everyone knows the news. So I posted on X. Some people get excited, but then never confirmed by DeepMind. And so it's a little bit weird because I thought like DeepMind will be the first one to kind of announce that news. And then at 1 a.m. Saturday, OpenAI starting posting, a lot of OpenAI people starting posting about like them winning the IMO gold medal, and kind of like stole the spotlight. And so I initially thought Google was just slow due to their marketing approval, like the process. So I posted another one to just like share my thoughts. And then I got pinged from Google, like someone from Google just told me that it's actually like IMO and Google themselves need extra time to verify. And so like kind of raised a question to me, like why DeepMind need to verify, but then OpenAI didn't need to do that. They can just release. And then it turns out like OpenAI actually didn't involve officially with IMO. They just like use the problems, and then just like use their model to test the results, and ask like 3 previous IMO medalists to review them. I think I read the proof. It's still correct, but it's just like less official, and that's why people kind of OpenAI receive a few backlash over the weekend, and on Monday, DeepMind officially confirmed they have the gold medal, and also fully verified by IMO. No.
Yeah, and I mean, so congrats. I think like the relationship between OpenAI and IMO and all that. I honestly, that's between them. What matters is that they have a model. Both labs independently achieved a model that reasons in natural language, without internet, without tools, which I think this time last year we didn't think was possible.
Yeah. So I have a feeling that this year there at least like an AI model can win the IMO gold medal, because last year by using like formal verification, formal language, Google DeepMind can already won a silver medal, and So maybe I should share some background about IMO. So usually IMO is basically the top tier competition for high school students, right? It doesn't require you to really understand like the advanced math. It's basically it's problems about simple knowledge like combinatorics, number theory, geometry, and algebra. But then it kind of require you to have very strong problem solving skills. You need to know how to do contradiction. You need to know how to create like counterexamples. You need to do like observation, etc. And so people treat this as like the one of the bar for AI to hit before they become the real mathematicians in the future. So last year, Google already won the silver medal, and seems to me that they already figured out a way to make it work. It's just like need a little more time, a little more resources, a little more data, a little more compute. And so naturally, I would say Google will win gold medal. What surprised me is this time they don't use formal language, but instead they just use LM. And so last year when they tried to do the IMO, they need like a human to kind of translate the natural language problems to Lean. And then they use Lean to kind of prove the problems, to prove solve the problems. And this year, no longer need that. And the same for OpenAI too.
Yeah, I think that this dropping the need for Lean and other sort of specialized systems, like I was covering this last year with the alpha proof and alpha geometry team. And it seemed like a very complicated system. Some of these solutions took 60 hours, which is way longer than the 4.5 hours that IMO limits have for humans. And so these some systems took up to 3 days. And I think that's a huge step. It's I don't even think it's like a incremental, like, scale this system more. They just have to throw away the whole thing and do something else. And then I think also, I think people can also just look up the problems. I think what's cool about you is that you can actually analyze and study the problems. I think that there's some different ratings or different pass rates of different problems. I think probably either problem 2 or problem 3 was like the quote unquote easiest, and it's like just a few paragraphs. It's not a lot, but like it involves a lot of creative thinking, right? Or what are they testing basically?
So I would say different problems testing different skills. For example, like the if you look at the problem 1, we can start from problem 1. It's like a combinatorial geometry. So it kind of involves like integer. You need to kind of it kind of asks you a question about all the possibilities for different cases, like for different n, for the any positive integer that greater or equal to 3, and so it requires you to find a key lemma, which is like for any n greater than 3, like let's say n equal to 5, you can reduce the problem to n equal to 4, and then reduce the problem to n equal to 3. And so this is there are different ways to do this, like induction, but like Google has one method, and then OpenAI AI also have another method, but both kind of works. Basically, you just reduce any n to 3, and then you just do case-by-case analysis for n equal to 3. And so I'll say this is probably not that challenging if you are very good like math Olympiads participants, but it kind of surprised me that AI can kind of come up with this like ideas too.
It's crazy.
And
go ahead.
How do you think about rating like the taste? I actually used to do Math Olympics too, but I got third. I never made it to IMO for Italy. And so it's hard for me today to judge, but how important is taste in your mind, where, hey, you can actually take then some of these results and maybe build on top of it, versus sometimes it's kind of competition for competition's sake. You know what I mean? It's kind of like with code. It's like, hey, look, you just wanted to compile. Like, is taste graded a lot in the competition, and is they useful, or do you think we're better off having models that can just brute force some of these things and we can focus on more interesting stuff?
Yeah. So I think I basically think like I basically look at my journey from like high school, high school to PhD, right? And I realized that IMO kind of like it's a good exam to test certain aspect of math skills, which is like problem solving, or you need to have like really complete chain of thoughts, like logic, etc. But it doesn't test like your creativity in terms of like research. It doesn't test your capabilities of doing conjectures. It doesn't test your capabilities of learning like advanced knowledge or like applying advanced knowledge. And so I think we probably should just treat this as like one stepstone for AI to become the real mathematicians in the future. And I would say most of the problems here are more like brain teaser style. So like you can solve them, but it doesn't mean that you are good mathematicians. And yeah, I mean, I can feel the AGI vibe from the solutions, but I think we're still not there.
Yeah, I mean, you did the CMO, right? Is
Yeah,
that
yes, yeah.
your background? How does it compare, by the way, CMO versus IMO?
So I mean, CMO is Chinese Math Olympiad, and so in terms of difficulty, CMO is kind of similar to IMO. I would say it's super competitive in China. So there is a saying like if you get, it's harder to get selected for the national to become the national team instead of then like getting the gold medal at IMO. And so it's similar. And I mean like there are many like it's all about probability. Like there's so many people compete at CMO, and so like a lot of students are pretty good, but just like 6 people were selected.
Yeah. I mean that's also very common in terms of any elite institution. It's harder to get in than it is to come out of it. Okay. Any other overviews of the IMO problems? I saw a minor piece of discussion around how the 5 problems that both AI solved were of the same kind, or the 6th problem was like a clear discontinuity, which I think is normal, right? Like IMO always has a 6th problem that is like challenging. This is part of like the Eliezer-Yudkowsky bet. But like I just wanted to, you're kind enough to prep some show notes, which we're going to publish. But you actually had some analysis of like the problems, and maybe you want to sort of talk about what you thought about the problems.
Yeah. So I would say for IMO there are like four categories, right? Algebra, combinatorics, geometry, number theory. Usually combinatorics is kind of the most challenging and creative, especially for AI. So like at one time I was at like this conference, which is a Frontier Math Symposium. So basically they invited like 30 to 40 mathematicians to kind of assess the capabilities of O4 mini high and many other advanced AIs. We realized that if it's like textbook stuff or like step-by-step problem, then it's AI can solve it. But however, if it require like creativity, especially like in combinatorics, you kind of need to create some example and then try to prove them that it's the minimal bound or like the upper bound, it's the lower bound of the upper bound. Then AI kind of sucks at it. And so I think this is why no AI can solve the last problem. But it also is super hard for human as well. And like if you look at the first 5 problems, you can basically, when you look at a problem, you already know how to decompose the problem into several steps, and then you know that if you can solve each step, then you can solve the whole problem. But then for the last problem, you kind of need to do a lot of experiments, or like you need to look at the smaller examples and try to create some solutions for that small examples and try to figure out if you can prove it. That is the minimal number.
How do you think we can get the models to do that? Do you have any intuition on how to get there, or AGI? Do you have an idea of like how can we get the models to solve those problems? Is it just a matter of better RL? Is it something fundamental about what data they need to get? Yeah.
So are you talking about the combinatorics problem or like the real research problems?
No, like these problems that you're saying, the format, you're basically saying, look, if the type of problem is this type, the models are not good. Do you know why that is, or how we're going to get them to solve them?
Yeah. So this kind of come to one thing that I'm just like doing as a hobby project, which is we think we need a better benchmark for math, right? Like most of the benchmark that people are using right now is like IMO, USA IMO, all these like competition math problems. But like they just test like a certain aspect of the math skills that a mathematician have. And so what we're doing here is like we really want to think from first principles, like what makes a human a mathematician. And then we break down all the skills that are required for a human to become mathematicians. And then we kind of create problems or like benchmark based on those categories. And so we kind of, right now it's like still in progress, but we're working with like several PhDs, professors, and like AI researchers in different AI labs together to kind of to produce like this more holistic benchmark. But basically, we kind of organize the skills into three categories. So one is mathematical knowledge and understanding. And so you need to know all the math knowledge, like definition, theorems, lemmas, etc. And you also need to understand theories, right? Like how to apply them, why they're true, what are the history of those theory. And you also need to understand how to do calculations, you know how to do like analytical skills, etc. And then the second is like problem solving and communication. So you need to kind of have a holistic problem solving framework. Basically, you want to understand the problems, you need to know how to explore examples, and you need to know how to apply key strategies like contradiction, decomposition, and analogy, etc. And the same, and then also you need to have logical thinking, and you need to be very good at writing and presentation. Then I would say for IMO, problem solving and communication probably is the most skills that you require. And then lastly is like learning, meta skills, and creativity. So you need to know how to learn new knowledge. You need to know how to how to think abstractly and then transfer tools across domains. For example, like you want to use probabilistic method in combinatorics, then you kind of know how to do this transfer learning stuff. And then mathematical modeling, right? You need to how to translate real world scenarios into formal mathematical models. And then generalization, which is you look at a few examples and you immediately come up with an idea. Okay, I can generate this to a more powerful theorem and see if I can prove that. And one very important piece of a mathematician is like creativity. So you need to very, very creative. Like when you look at one object or one example, then you basically say, okay, now I think I can invent some new methods. I can invent some new theory. And lastly is like intuition. So you look at for example, the geometry, you look at the geometry problems and you kind of already know, okay, these two lines are parallel or these two lines are perpendicular, or even just look at algebra problems and you know like, okay, this group has this structure. And so those are like the main pieces I think will define a mathematician. And then in terms of how we can get there, I think it really depends on different skills. So for example, for the logical thinking and reasoning, I think we can, a lot of people trying to use Lean, because like RL works super well for verified domain. And so if we can just use Lean to kind of become the verifier, then it's easy. So I think we probably will see very powerful reasoning models in math very soon. But then for creativity, this is a little bit hard because there's no measurement
Increase temperature.
Yeah, this decreased temp. No, we want it to be more creative. Increase.
Yeah.
But then you also need to have the taste, like, right? You need to know like which direction is right. Like this is a common problem in IL, and so I would say you need a new way. Like you need to define a new reward function to kind of capture how good this model is in terms of creativity, and just like it need like specific domain knowledge to kind of create this reward. And I think I started seeing more and more mathematicians working together with AI scientists, researchers, and I think this is a good combo because if you are just like AI researchers, you actually don't know what makes a mathematician good. Then there's no way that you can come up with a reward function well. But then if you're just a mathematician, you maybe know the concept, but you don't know how to apply that to AI research. And so basically, I think we will start seeing more and more mathematicians working together with AI scientists. And my guess, I mean, different people have different opinions, and then my guess is I believe in IL. So if for each category we can figure out a way to auto evaluate the results, then after that it will just be compute and data.
Yeah. I just want to offer a few links for listeners and viewers. This is the symposium that you went to. It was 2 months ago, and these are the people involved. And this is obviously leaning on the frontier math work that was done by Epoch and OpenAI. And this is some of the example of the kinds of problems that they're working on, which is like not even English to me. But like, yeah, I mean, I think it's very nice how you broke down the different levels of reasoning. I feel like this is very cool in a sense of, yes, this is particularly applied to math, but it does generalize. It does generalize to like, this is how these are like the higher level skills of intelligence other than predicting the next token, that, that people want. And so you have a framework of like, knowledge and then going all the way down to communication, which is actually really cool to me. I'm going to think about that a lot more.
Thanks. Yeah. Stay tuned. We probably will publish the first version in a few weeks.
This is a different work from the frontier math people. Okay.
It's so frontier math still problem focused, but then I think we need a more skills breakdown.
Yeah. And is this like is this related to hyperbolic at all, or is it like a personal project?
So I mean, hyperbolic. The goal of hyperbolic is that we want to democratize AI innovation and try to accelerate AI evolution. And so I will position this as a hobby project, but we will probably give people some credits if they actually can solve we'll give some researchers some GPU credits if they can actually solve some problems in the benchmark.
Yeah. And then I think the last follow-up I had was about a comment that you made, maybe like 3 comments into your comments, which is about the usage of lean and then like sort of verifiability. I saw some mathematicians actually say like, so, okay, on the one hand, if you're very bitter lesson pilled, and if you're very pro scaling AI and all that, it's a win to reason purely in natural language, purely within your weights, no tools, no nothing. The OpenAI output was very raw. It could have been fine-tuned for human reliability, but like it was still fine. Like it still got the right answer. GDM was a bit more polished. But ultimately, the answers were hard to verify. You had to hire like 3 former IMO gold medalists to go and read it and then say like, yeah, this looks right, instead of like, no, they didn't get lucky, or they just got lucky, right? And I think like I saw some arguments from mathematicians that are saying like, actually, using lean is good because then we can trust that is good reasoning. Do you have any perspectives on that stuff?
Yeah, I think. The different approach have different challenges. Like natural language is easier to gather data, but it's harder to verify. But it's more human readable, right? For lean, there are not enough data for lean. right? There are like probably 1 million tokens in about Ling right now, and I know a lot of like professors and PhD researchers are trying to build the biggest Ling dataset in the future. If we can reach like 1 trillion token, I think then you can start doing some cool AI training on top of that. But I think that's like a more, personally, I feel like it's probably a more clear approach. I was super surprised when I saw OpenAI and Google DeepMind didn't even use Ling and can solve that. And as many one know, like AI neural networks is basically a black box, and it's like experimental science. So I can't make any prediction whether we will first see like a mathematician AI built on top of Ling or built on top of natural language. But by general, I feel like both approaches should work, and I think mathematicians will like both of them. And besides that, anecdote, I know some professors in London are trying to using Ling to write the proof for Fermat's last theorem, and so that's pretty impressive if you can do it. Yeah.
Do you think it's possible? I mean, I knew that Fermat's last theorem has been proven, but
Yes.
Also I don't know if Lean is complete enough to get to that level.
So I would say it's I think definitely possible.
Yeah.
Like so the professor is Kevin Buzzard, and he got like a grant, and now he just like focused on writing the proof for Ling. Like he's hoping to finish that in like 2 or 3 years. And then basically like if Ling is not complete, then he can just build more libraries on top of that. So everything is doable. It's just time, and I think he got time and he got resources. So I'm very excited to see that happen.
Okay, cool. Well, looking forward to the skills breakdown. We'll share it whenever it comes out. Any other thoughts on just this IMO chapter of I guess the 2025 edition of the IMO? Any speculations on like what breakthroughs either lab has done?
Can you say that again? What do you mean by breakthrough?
Do you want to speculate? Is there any credible speculation on what has been the breakthrough that either OpenAI or GDM have done in order to achieve this? Like, they all they say is like, oh, we scaled test time scaling more, but like, I don't think that's enough.
You don't think that's enough? You don't think like I to be honest, I feel like a lot of AI. Like a lot of AI models built in industry is just like a bigger scale of research results. They probably will use like existing research, but it's just more like larger scale, more systematic, and more data. I mean, I know when I read like the Google DeepMind report, they said they can now do like parallel thinking. Basically, the model can like parallelly try different new ideas. They try to like leverage more multi-step reasoning. They try to like figure out new reinforcement learning techniques that can leverage multi-step reasoning. I think that's probably like a very important step. I know Al is pretty bad at multi-step, but now seems like they figure out a way to kind of train using Al for multi-step reasoning, and I think that's like pretty impressive in terms of the solution. But then I would say none of this will probably be worth like the best paper at NeurIPS, but it's more about like you just be the best in terms of each technique and just get more data, get more compute.
Yeah, a lot of people are focusing on this sentence where they say we provided Gemini with access to a curated corpus of solutions to math problems, and they were like, oh, okay, like you train on tests.
It's not.
But no, but I think a smaller covered story that people may have missed is that there was a second Gemini model that was also submitted to IMO with no in context learning, and they also got the same result. So yeah, that's a big win.
Wow.
Yeah, I think it's reasonably known that DeepThink and O3 Pro and Grok 4 Heavy are all like parallel thinking, right? Like they all just run like 10 different variations of the same model, and then they have a judge model choose the best result. I'm not sure. Like I think the existence proof that there's been something qualitatively different is the wall clock time going from 60 hours to under 4.5. That's an order of magnitude change, and it is not that typically that is not achieved by scaling up existing ideas. You have to just do new ideas because it's an efficiency issue.
Can we GPU getting better now? You get B200 is faster. Like even
is it one order of magnitude better? I don't think so. It's like 2 times better.
2x, and then inference speed also improve a lot, right? Like if you look at if you want to run like Llama 3 and like now compared to now, it's like 3x, 2x better. So kind of
yeah. maybe.
But I definitely agree. It's also like the model is more powerful, and you can solve the problems faster too.
Cool. Any what's next? What other like IMO? What other math like you have like frontier math. You have your benchmark that you're putting out. Any other like milestones that you're looking for in this part of the world?
Yes. So I would say a lot of benchmark is just like exams, right? Like the purpose of becoming a mathematician is not to take exams. It can give you like it's the same for any job too. It kind of give you a benchmark or like a matrix to see how good these models are, but you really need to put them into the battlefield, right? And the goal of a mathematician is you want to push forward the frontier of math. And so I would say the next step is trying to solve some open problems that's like open for 30 years, 50 years. And then I think the ultimate goal is to solve like a very challenging problem, or like create a new theory and then win a Fields medal. That's how I define math AGI in the future. Yeah.
Field medal. Okay, let's go.
Yeah. That's my dream.
Cool. Alessio, any parting thoughts, questions?
No, that was it. Maybe I should go try back and do the problems this afternoon. See what
let's solve some IMO problems together.
Yeah. Awesome, man. Thanks for joining us.
Yeah, thanks for inviting me.